All right, so I believe this is approximately where we left off with yesterday. Let me back up one. Yeah. Okay, yeah, I think that is correct. Yes? Okay. 10 minutes from now? Oh, okay. You bet. Bye. All right. So, yes, I do believe this is where we had left off with yesterday. And let's see here. And this will be part of our reactions that we go through and how these actually form. And we'll talk about some of the different industrial uses they have. Of course, some of them could be that of medical use, and at least it used to be, at least before we had different types of anesthesias to put people to sleep for different types of surgeries. All right. So moving on with these organic derivatives formed from water by the replacement of hydrogen, we'll talk about a lot of that. Maybe touch a little bit of that next week on Monday and Tuesday. As we all know, it's a short week at that time as well. Okay. And one of the things that we have behind the screen here is we'll actually show you some of the different naming aspects. The author really doesn't go into that great of a detail, so one of the things we want to do that is take a look at that here in just a couple of moments. Okay. And one of the things, we have done this with Markovnikov's rule. You just didn't really realize it at that time. And just adding that of water gets you to form these alcohols. Okay, so this, we'll get into that. That's more so of the reactions, okay? And we will look at some of the isomers that we'll have behind here. That's what this is referring to, of course. You would have to have more than 2 carbons to form an isomer, and that's what we're illustrating up here. And I'll show you what that means here in just a moment. Okay, so that's all for the note-taking. There's a few things behind the screen you want to take a look at, and we'll go ahead and do so. Okay. So what we're referring to when it says you have to have 2 or more carbons, because if we just have these 2 up here, so we know that that's ethanol. Here's our OH group here. If we put it on this side, it's still ethanol. And if you just had 1 carbon, of course, there's just nowhere else for that OH to attach. It's still just going to be methanol no matter where you put that. So just like naming every other compound, we just go ahead and go through and find the longest parent chain. Okay. And of course, with that being 4 carbons here, the prefix, of course, would be this. And then there's our organic family, so we've got butanol. And an isomer of butanol would be, is if we take this OH group, we're going to take him off, the first carbon, and we'll just put him over here. We can come in from the other direction, okay? If we put the OH group here or here, we'd still have the same compound, still be on the second carbon. So we still have butanol. The only thing we need to do is just name where that OH group is, and it's on the second one. And notice, nothing is coming after that number except the dash. So what that is telling you is where that OH group is located. So on the second carbon, because this is butanol, here's our organic family, that's referring to where that OH group is. Right there he is. Okay. The next compound, as we can see, is just 1 carbon longer. 1, 2, 3, 4, 5. So we can safely put that as our parent chain. Here's our organic family, the OL. And there again, if we don't put anything behind the number, that's referring to where that OH group is located on the second carbon. So an isomer of this, we could do one of two things. One, we can take this OH group and move it over one. Now we've got 3-pentanol. And notice again, we can't go any further because if we put it on here, we would still have 2-pentanol. You're just coming in from another direction. Okay, so if we do this, we could also take this guy off and put him down here. This would also be isomer, and that's what we're kind of getting to over there in the lower right-hand corner. Okay. Go ahead and erase this. All right, so here, 1, 2, 3, 4, 5, parent chain, still pentanol, okay? But here, notice we have a derivative branching off the parent chain. That's why it's written in blue. I guess I don't know if that really shows up on, yeah, I guess you can tell that on the computer. So in this case, we want the lowest combination again. And with this, we're going left to right. We've got a methyl group on the second carbon, and because we're going to name the alcohol last, or where that's located. Okay? So what we see here, okay, is on the second carbon again, we've got a methyl group. So 2-methyl-2-pentanol. Okay? So we reverse engineer this. Again, here's our organic family. So somewhere we know there's an OH group because of the OL. Okay? So now when we look at this, it says, okay, we got an alcohol that's 5 carbons long. 1, 2, 3, 4, 5. Okay? So on the second carbon, there must be a methyl group. Okay? 1, 2, there it is. Nothing's written after this number like there is on this one. So if there's something written after the number, it's telling you where that derivative is. Okay, so it's on the second carbon. And in this case, okay, nothing written after here, so it's telling you where that OH group is. We could change that just slightly by doing this. Okay. We'd still have the same compound, 2-methyl, then 3-pentanol. Okay. And then finally, this last set, we still have pentanol. But I'm going to leave a space there for a very specific reason. Because now, notice that we've got 2 OH groups on there. Okay? So they're located on the second and third. All right. And what that means is typically we would put 2,3-dimethyl. That was something that you would learn the second and into the third week of school. But in this case, it's written just a little differently. The di portion would come back here. Okay? 2,3-pentanediol. Okay? So what this means, we still have our organic family is an alcohol. This is telling you that you've got 2 of them, all right? And then this is telling you it's 5 carbons in length, just like it always has. And in this case, it's telling you on the second and third carbons, we've got those OH groups. All right. Last thing I want to do is I kind of ran out of room here, but just illustrate where we left off with yesterday. That was with this. This OH group was on the end. X marks the spot. This is a primary alcohol. Okay? Notice in this case, X marks the spot again. That carbon is connected to two other carbons, so this again is secondary. I think the more we see this, the better off we're going to be. So primary, and we'll get into tertiary alcohols once you return. All right, so it's Friday. All right, we're running in the right direction. Excellent job yesterday, ladies, and we'll see what today rolls out. All right, that's all I have. We'll catch up to you next time.